Hey, welcome to part 2 of unit testing in embedded environment with ESP8266, Visual Studio Code and PlatformIO. My name is Thomas and this is day 33 of 100 Days of Code in IoT Challenge. Let's get started. Let me remind you first where we finished yesterday. Okay, so I've got this project. I'm gonna keep working on it. And that's supposed to be, at some point, the library with all the tools, all the classes that I have in the core library at the moment, right? But this is gonna be the part of the framework now. Okay, so yeah, what we've got here is the tests from yesterday. So we've got two types of tests, desktop and embedded, right? Desktop, they just run on my own environment, on my own machine, and embedded, it runs actually on ESP8266, right? So the code gets compiled, uploaded to the device, and run there, right? What else I've got is these three functions: add, multiply, and set built-in diode. And each of these functions have the tests in the test files, right? They sit next to the actual production code, right? And this is due to the way these tests with Unity work. But anyway, this is all from yesterday, right? So you would like to get some more details about Unity testing and how to configure everything for this test to work. I suggest watching yesterday's video. There is a link in the description, okay? Right, so yeah, now to today's challenge, which is installing GoogleTest and trying this out instead of Unity. So I'm gonna start from cleaning up, okay? I'm gonna completely remove test embedded. And for the test desktop, what I'm gonna do is to remove Unity from here and clean up the main function. Also, all those tests, I'm just going to remove as well. So we're gonna start somehow clean, okay? Clean the way that we have our production code, right? Again, like yesterday, we're not gonna be doing test-driven development yet. That's gonna be tomorrow when I start building some more useful libraries, some more useful classes. For now, this is just a presentation on how to do testing, unit testing in general, okay? So yeah, I'm gonna keep these three functions. This one is very simple, add. It just adds two numbers, two int numbers, right? Multiply multiplies, and set built-in diode really sets the given state to the diode, right? It writes to it, to the built-in LED, okay? And for the bootstrap CPP on the test desktop, we have an empty main function. What I could explain as well, for those who haven't watched yesterday's video, is the way you configure the tests to run. Right, so the first step usually is to add a second environment, unless you want to test everything only on the microcontroller, right? So then you don't really need to do anything except for creating adding your tests to the test folder. But if you want to have a possibility to run your tests faster, right, without deploying the code, waiting for the deployment to the device, you can use a native environment, which is this machine, okay? Okay, and one additional thing to mention is this test ignore entry for the Node MCU v2 environment and for native environments, right? They are different. What does it mean? That simply means that if you put a folder inside the test and you call it test desktop, anything that is inside, any test files inside this folder are not gonna run on Node MCU v2, right? And on native, that applies to test embedded folder, okay? So essentially, it is to tell the test runner to, not run the desktop tests on the ESP8266 and to not run the embedded tests on the native on the machine, on this machine here, because it wouldn't work anyway. Cool. Right. So yeah, so now what I could do as a first step is to, I'm thinking, let's install with PlatformIO, let's install that Google Test library, okay? So we go into here to quick access and then to open and libraries. And here I'm just gonna type Google Test. And it should be the second one. Yeah, it is the second one. So I'm gonna click and add it to the project. My project is called UniUno. And I'm just gonna press add. Essentially, what does it do? You don't really need to use this libraries and add to project. There is a shorter way actually, but you need to know the version, the latest version, because what it does really is it adds an entry here to platformio.ini, right? You have libdeps dependencies, and there is Google Test on Node MCU v2 now and in the native environment as well. Okay, so we've got this installed. One more step that has to be done, and this is due to the Google Test not having as a library in PlatformIO, not having a support in their configuration for ESP8266, even though it actually works with ESP8266. And for that, there is one additional setting to be set, which is libcompat mode equals off, right? That switches it off. It might actually work without it, but just to be safe, it is good to add this entry. And another one, which is going to save us some time with debugging, is to add the build flags and to tell on the native environment to tell that we use C++11. So that's essentially gonna compile the code with the flag C++11. That's the version of C++ that runs also on ESP8266. Okay, so with this configuration, we can go ahead and initialize Google Test Testing Framework. Okay. In order to do that, I'm gonna open bootstrap.cpp and I need to add something to the main. And that is, I've got this prepared. So that's how it looks like. So we include Google Test header, and then inside the main, what needs to be done is to run the init Google Test with the argc and argv. And we need to run all tests macro, right? That's it. You don't need to do anything else. You don't need to specify every single test here that you have in other files. Okay, so that's like also this is actually something to have a look at. So yeah, you don't need to include anything here. Okay, it's just that, and that's gonna ensure all the tests inside the desktop folder are gonna run as long as you use the Google Test macros. Okay, and for that, let me start from creating a file, add test cpp. This is where I'm gonna test this function again, but this time with Google Test, right? But before I write any code, let's quickly go to the primer, which is the introduction to Google Test. I think this is worth mentioning. You can find link to this website in the description of the video. You can find all the information here. I really recommend reading this entire page, the primer, before you start writing any tests. It explains it very well how this all works, right? The basics about the testing framework, which again is very similar to the other one, which is the Unity. Okay, you still have the assertion macros, as you can see here, right? You have things like assert true, assert false, assert equals, not equal. This one is less than, less equal, greater than, great equal, and so on. Okay, but there is more. You can compare strings. And this is how you define tests, essentially, okay? So let me actually copy this and paste in here. Obviously, the test body needs to be replaced with whatever we wanna test, and also we need to include the header. Okay, so having the header, here 2 arguments in the test macro. The first one is the name of the test suite, and I usually just put the subject that is under test in here. Okay, so in our case, the subject under test is add function. So I'm gonna just type add, and the second, this can be anything. It's supposed to be test name, but usually what I put is like is the description what I'm testing, the behavior that I'm testing. So what I'm gonna do is to just put here something like test if maybe test 2 given ints are added, something like this, or maybe test it returns sum of 2 given ints. Okay, so that essentially just describes what that test is gonna do on this, like what is the specific behavior of that subject that we're going to test in here, right? Okay, and now we're gonna open that as well. So what we're gonna have to do to test add is to include it, right? So we'll have access to it. And again, what we can do is define our expected. Let's say this is 5 now, and then our actual is gonna be add. You know what? Maybe let's do this as a sum. So we'll have the sum here as well. And then we're gonna do just asset equal, and that will be expected and actual, right? What is good about asset equal, I think you don't actually need to specify the type, as long as it is not a string type. I think this is gonna give us a pretty nice output, even if the test fails, right? It's gonna tell why exactly it failed. So not like with Unity where you had to use assertions for the specific type. But let me verify this because I'm not 100% sure. Okay, so yeah, now we're gonna run this, and to run that, there is no difference to how this is done with Unity test framework. What you need to do is to do PIO or PlatformIO test. And that's gonna build it for us and run the test in a few seconds. There we go, okay? And that obviously that has succeeded, okay? But to make sure this is all really works, I'm gonna break the test now. So I'm gonna go to the production code and maybe let's add a 1 to it. So breaking the test on purpose without having to change the implementation, the code of the test. Okay, there we go. So what we got? We've got an error that failed, right? And here it actually tells us why, right? Expected equality of these values, expected this which is 5, actual which is 6, right? Question is, what happens if I compare maybe expected to something that is not an int type? Let's see what happens. Oh yeah, it doesn't like it. You see? It doesn't like it, so it won't compile if you try to compare two different types. But again, what if I actually compare two different strings without specifying, without telling GoogleTest I'm actually comparing strings? What this is gonna do? Oh yeah, okay. You see, you get full information even though you didn't specify your type, okay? So in this case, expected equality of these values, we have like JSD, And that even shows us the address here, I think. Or is it a hexadecimal? I'm actually not sure. It might be address in the memory. And then that tries to compare to JD, which is this one. I can actually make sure if this was, I think this was an, oh no, that's just the, I think this is just hexadecimal representation of this one. But yeah, if it's addressed, yeah, just let me know in the comments. Anyway, what is important to us is to get those values right, we compare, right? If the assertion fails, we would like to know why the assertion failed. Okay, so that is on assertions. About having a multiple files here. Again, there is no issue with that, unlike with Unity, where we had to, you know, go sort of different approach where the test files need to sit next to the production code, which is not bad, right? It's just a different approach. These are two different approaches, okay? But the problem is that the framework actually forces you to do it if you want to use multiple files. Again, I'm not 100% sure. There might be other way, but I couldn't find it easily, right? So that's also the point. If it was just somewhere there explained in a nice comprehensive way, then yes, then it's fine. But if it is something I need to look in the internet, on the internet or on the forums, you know, I give it, I take it as a slight, you know, disadvantage. But yeah, anyway, let me show you how to add another test and simply multiply test just to make sure it's all good. I will also try the approach where you put the files next to SRC. However, I think that needs some additional overhead. It's not much, but you're probably gonna have to include all of those files. So still, it's not perfect, right? Comparing to just having it there. But yeah, let's see. Let's start from just adding a multiple. So I'm just gonna copy paste the add and slightly modify this, right? Because now we're gonna test multiply, and we're gonna return product of multiplication, okay? Of multiplication of two given ints, right? In this case, it's gonna be 2 times 3, and no other changes, right? So I'm gonna run it now, and let's see if that passes. Yeah, sorry. That needs to be multiply, obviously. So PIO test, and there we go, okay? Right, one additional step that I usually do if I don't do test-driven development is to break the production code on purpose to make sure the test is actually working. Okay, that is working, right? So expected was 6, but we got 12. So that means the test is working well, right? One more attempt, that's it, right? That's it. Okay, what if we move those to SRC, right? I'm just gonna move them there. I'm probably gonna have to change extension though. Yeah, I mean, like, you know, in my opinion, in this environment, this might not be the best approach, but you know, it's just my subjective opinion. Right, if I do just that, if I just run PIO test, I don't think this is actually going to run those tests. No, that runs 0 tests, right? So what you're gonna have to do again is to go to the Bootstrap CPP and include those files, right? So this is not perfect. This is not perfect. Maybe you could tell the test runner somehow. Maybe you could tell the test runner what folders to scan when it's looking for the test. Maybe there is a way to do that. but I'm not really gonna be investigating this because in my opinion, it is just, you know, as you can see, yeah, by the way, this is working, right? If you go with this approach, this is working, but again, you have additional work to do, which is adding all the includes, right? Which I don't really want to do. And in that case, I'm just gonna keep all the files, all the test files here, right, in the test folder. Especially that, you know, this is not gonna be very big library, right? It's gonna be bigger than the usual library, but not very big. Hang on, there is something wrong now. It didn't run any tests. Ah, I know why, because this is HPP now, it should be CPP. Hang on, is it the case with the extension then? No, it's not the case with the extension. Okay, anyway, as I said, I'm just gonna stick to this structure where all the tests are kept inside the test directory, either in the test desktop or test embedded, depending on the type of the test, okay? So that's gonna be the approach I take for the entire framework. Right, cool. So yeah, this is on the example testing, example unit testing with the Google test, right? This one is for the native environment. And now we're gonna write an embedded test. So embedded test, we test embedded, right? Like this one, test embedded. And the best approach again is with the bootstrap file or setup file, you can call it, you know, however you want. And how you initiate these tests, it's very similar, however, there's no main function. So we're gonna need to modify that for the embedded environment. We're gonna need to modify that to setup, where we don't have any arguments, okay? So we're not really gonna call the init Google test with these arguments, and there is nothing we can really return. So that's gonna be something more or less like that. So this is the only thing that is required to initialize and start all of these Google tests. However, that's not everything, okay? Because we still need that, right? We need to initialize serial monitor with the same baud rate as we set for the monitor speed. It is quite important, otherwise we won't get any output. And also what is recommended to have a small delay of 1 second. It's just it was 2 seconds, but 1 second is enough. I checked it. It's just recommended by the PlatformIO. It can be found in the documentation. It was like we've done with the Unity test framework. Okay, cool. So yeah, let's write the test now. Yeah, one more thing before I do that. A loop function needs to be defined, and we also need to include here arduino.h, because this one runs in embedded environment on ESP8266. Cool. And now I'm going to add a specific file for the specific test for built-in diode. There's not much difference to how this test is supposed to look like. So I'm going to copy paste from our native test, but we're gonna add a different include, which is a set built-in diode. And this is also gonna be set built-in diode. And what we're really testing is test it set built-in maybe like that diode to the given voltage, high or low. maybe something like this to indicate that this is not the range, but you know, just two values, high or low. Right, and this code is not gonna really look like that. It's gonna be slightly different, which is what we're gonna do. So in our case, what we want to do is just run set built-in diode, and that is gonna run with oh, okay, that's slightly different, because we would like to test two cases here. We would like to test again high and low, right? Like we did yesterday with the Unity. So it sets built-in diode to high voltage. When the given voltage, maybe the given value is high, and we're gonna have another one which is about low, right? So it sets the built-in diode to low voltage when the given value is low, right? And here this is just gonna be as simple as doing here we got high, and here is gonna be low, right? And for the assertion, what we would like to check is with the digital write, right? So this is gonna be different. There is no result. There is no written value on the set built-in diode. Right, so what is our expected value? Expected value is high, and the actual one is the digital read on built-in LED. And that's how it looks like here. And to be honest, to make it even more verbose, what we could do is to specify expected as high, here as low, and just pass expected. So if we ever, sorry, that should be like that. So we ever need to change that value on expected, or copy paste that code to write another test or something like that, it's gonna be just easier, because it's based on this helper sort of variables, okay? And this one, for the actual one, we can keep it like it is. Yeah, like it is. Right, so yeah, so we've got this finished, and let's try it out now, okay? So I'm gonna run PIO test, and let's see what is going to be the output. Right, some complaints about the wrong constant. I think there should be LED built in or something like that. Maybe I change it while this is uploading. Yeah, there should be LED built in. That should be the name. And also this one. I mean, the other one still works, but it's deprecated, so. Cool, okay, so yeah, that's been uploaded, right? On the microcontroller. I forgot actually to tell, you need to connect your ESP8266 to the computer to run this test, because it runs the code on the board. You can actually see the built-in diode switched on, and this is because the second test actually switches it on. If you remember from the second video, right, it was actually a long time ago, if you set it to low, like it's contrary, right? If you set low, then the diode switches on, right? It's just for built-in diode. Cool, so yeah, that run, that has been successful. However, you might have noticed I cannot do anything here, right? It didn't stop. That's for PlatformIO, it still thinks that the tests are running, and this is known issue. What I'm gonna have to do is to just press Ctrl+C to abort it, and yeah, that's a known issue with the support of GoogleTest for embedded testing with PlatformIO, and it has been reported in the PlatformIO core repository on GitHub. Better support for GTest in non-native environments. It's open, they are working on it, but it might take some time once this is resolved. There are two ways to fix this. One is with change of the Python script that runs the test runner for PlatformIO, and this is a more complicated way. Let me show you the other way, which is way simpler. So to fix that issue, I'm just gonna paste that in. I figured it out myself. It's this is due to the fact that PlatformIO it stops the test runner when it detects a specific string in the output, and that string apparently is tests, failures, and ignored. It's coming from the Unity test framework. So if you print this out after running the tests and you add this additional string pass or fail, you can actually make this all work, like fix the issue, and let me show you, make work the same like with Unity. So I'm gonna run those tests again and you will see. Okay, there we go, right? So now we've got pass, because that printed out test failures ignored and pass, and that was considered by the PlatformIO test runner as passed, okay? So that's how this looks like with the workaround. So if that issue, if that issue is not resolved by the time you're watching this video, I just suggest to going for this workaround. You can find it in the description of the video. There is a link to the piece of code that you are supposed to paste in, okay? Okay, one more thing, which is trying to deliberately break the test. So I'm gonna comment out pin mode, right? You remember, if we don't set the pin mode to output, then you cannot really change the state to, I think, to low. I think the low test is going to fail. But yeah, let's have a look. Let's see how this is actually gonna be. So now they should fail, right? The test should fail. And there we go. There we go. Which one has failed? Let's see. It is the low, right? Is low. Sets the built-in diode to low voltage when the given value is low, and that's line 15. Expected equality of these values, and that is expected, which is 0, and digital read 2, which is 1, right? That's how this looks like. It's not perfect, right? I mean, you see sometimes there is no new line, for example, here. I think this is, again, due to the way the test runner displays all of this. And you cannot really click through to 15, so you need to look at yourself. I think this is because, yeah, this is it's taken as a single line. There's probably something you could do with the Google test itself, the way this outputs all of this information. But again, like for me, this is enough. This is enough to work with Google Test, and I don't see this as a big issue as long as I can get the exact information on what has failed. I'm just happy with that, right? Cool. So that's how you write example tests with Google Test. Let me show you now how can we do mocks, because that's something we're gonna be working quite a lot when I be building this library, this framework for IoT. And for the mocks, I'm thinking of starting to test the actual core library, right? So let me, as a first step, remove all of these example files and also example tests, not the bootstrap though. because oh, actually I did wrong. So we're going to do this. We're going to remove this. And we're going to keep it this for now, maybe, because for some copy pasting. Cool. Right. So now I'm going to paste into SRC all the files from the latest state of the core library, of the ESP8266 core library, and that's gonna be turned into UniUno, ultimately the framework, for now just library, with all the tools needed for IoT development, for the fast IoT development, for prototyping IoT devices, okay? So again, this is not meant to be very low level embedded, like, you know, as for production grade embedded devices. That would be the second stage. The point of that framework is to have set of tools for the production grade prototyping. Okay, once you have a prototype done, test it on the market, that will be the moment to think about more, like, you know, maybe low level C approach to your IoT device. Right, so work on the performance, work on cutting down the abstraction or something. But, you know, that's again up to developer, and it depends how you think, as the creator of the device, okay? Because you might be, like, you know, more business oriented, like I am. So the abstraction and the ability to move fast is actually more important to me than having everything done, you know, like 100% perfect and so on. Anyway, yeah, let's pick one class from here, maybe EventDispatcher, and let's try to test it. Right, EventDispatcher is a really good example because it doesn't need embedded tests. That's just native code, right? You don't need to use Arduino.h in here, right? Oh yeah, one thing that I have done myself, but it's not in the latest stage of this latest state of this code, is the include for the vector that is required for EventDispatcher. So if you don't have that, add it, otherwise the tests are gonna fail, right? So EventDispatcher, and here I'm gonna start from creating a file, EventDispatcher test.cpp, and this is why I kept that file, because now I can just copy paste here. I can remove that file now and then just change the include and also slightly modify this macro. Okay, so we're testing EventDispatcher. We're testing EventDispatcher, and we would like to test something on the EventDispatcher. So I'm gonna remove the body, and let's think about the name. I mean, to think about the name, we need to think about what we're going to test, what is gonna be subject of the test, because it's not just EventDispatcher. EventDispatcher is a class. It's not a single function where it's easier, right? Where it's easier to just, you know, by looking at the function to tell what is the subject of the test, right? So in our case, it is EventDispatcher, but not just EventDispatcher. That is gonna be really on the method, or sometimes combination of the methods, which is the case here for EventDispatcher, because really, if we think about the behavior of EventDispatcher, this is all working in a way where you first set the listener using on method or once method, and then when the same event is dispatched, all of the listeners that you set are gonna be notified. Okay, so on essentially notifies all the listeners whenever that particular event that those listeners are listening to are executed, right? So the event is dispatched, and all the all the listeners assigned to, like, you know, waiting for that event are gonna be notified whenever that happens, right? Whenever the event is dispatched. The behavior is slightly different for once, because once really removes the listener once the event has been dispatched, right? So this is only these listeners for a particular event. A listener can be only notified once, right? After the dispatch. But yeah, what we're gonna do is to look at the on first, right? So let's think how to test on, right? So that needs to be in connection to dispatch, right? We still need to call dispatch to make sure, right? But again, right? So for on, the way I see the test would be to set ideally 2 listeners, right? Because we want to make sure all of the listeners are getting notified. So 2 listeners we're gonna set on, and then we're gonna try dispatch 2 events of the same type and check if those events went to the listeners, right? So if those listeners has been notified. So we're gonna have 4 calls in total, right? We dispatch the first event, we should get 2 calls on 2 different listeners, and then we're gonna dispatch a second event, and we should have another 2 calls on the same listeners, but with different event body, right? The type needs to stay the same. It just needs to be a different body. So yeah, let me show you how to write this test. So now we have a name, right? So we're testing on method. So test on. So now we know what we're testing, right? We're testing the behavior of EventDispatcher. So what we could do is to write something like test listeners set with on method will be notified, or maybe has been notified. Maybe the past tense is better. So have been notified for each event of the same type, for each dispatched event of the same type. Okay, so test listeners set with on method have been notified for each dispatched event of the same type, right? So it doesn't, yeah, I think that explains it well enough, right? So that's what we're really testing here. Cool. To test that, what do we need? An instance of EventDispatcher. So I'm gonna create it here maybe. Or maybe inside the test, right? So we'll have that independent. Cool. So dispatcher is created. This is all, yeah, that's all working. And what we're gonna do now is to set those to set these 2 listeners. So we're gonna have on, and that will be on the type. Okay, so for type we need some sort of the event. So maybe test event. Test event is gonna be our type, and as you probably remember, for that we need a static const expression const char pointer. Unfortunately, it's so long, and we're gonna call it test maybe. So that's gonna be the name of that static member, right? Static member. Cool. So now we know this is a test event, and here we're going to take test event pointer, and this is gonna be the actual listener, right? And we need another one to be set, something like that. And then we will have something like a dispatch, and we're going to need to dispatch two events, two different events of the same type, right? So to be able to distinguish them, I'm thinking about adding some maybe const char as well. Let's call it ID. So here I'm going to create test event, and let's call it E1, and that will have an ID of 1, 2, 3, const char, and let's create E2, maybe 2, 3, 4, right? So we will have the same type, but different ID, so we can distinguish them. And here, what I'm gonna do is to just dispatch them, right? So we dispatch this one, and we dispatch this one, right? So this is how this code is gonna look like, but we've got something missing, and that missing part is assertions. We don't have assertions because if you think about this, how are we supposed to do these assertions, right? This is sort of different because we need to have a way to tell whether that event listener and that event listener have been called, right, after the dispatches. In order to do that, there are two ways. So one way would be with just C++ code, what we could do is to define some integer here maybe, and then just increment that integer here somehow, right? We could make it global or something and just increment it and then check if that has been incremented twice. So that's all fine. We could check whether with that integer we could check, like, you know, something like that. I mean, this is not really gonna work exactly like that because you probably need to make it global. That would be the simplest way. Or you could put it as a capture, but then you would have to do it as a pointer. But yeah, anyway, so that would be one approach, right? So you just increment it, and here you could have something like an assertion. Assert equal, and that just would be I and 2, right? So you to make sure, that would be 4. That'd be 4, right? Because those two, they need to be called twice. So you could do something like that, right? You could do something like that, but this is not everything. This is not testing everything. It just tests whether they have been called. But I would like to make sure they have been called first with this event, the pointer to this event, right? So the first call should be with E1 here, and the second call should be with E2. In order to do that without any external help, right, without any mocks, because I'm gonna introduce them in a second, you would have to, create some sort of container maybe, and then put it here as a capture, but pointer, and add things to the container as they called. But again, you're risking that this is going to go out of scope, and so on, right? That would make it very problematic if you wanted to do it yourself. I'm not saying to not do it yourself. There might be the case where you would like to do it yourself, but because I would like to move fast, that's the point of this whole thing with IoT framework, to move fast, to prototype fast, and also to write unit tests fast. And to move fast with that, I can use the built-in mocks in GoogleTest. And that's what I'm gonna do just now, right? So I'm gonna remove this that assertion. I don't need that. Instead, what I'm going to do is to create a mock class. To create a mock class with GoogleTest, let me show you how to do it. So this is very useful on the documentation of gmock, a cheat sheet, and that's how you define a mock class. So you need a class, the abstract class, right, with the virtual methods, and then you use the mock method macro to mock a method on that class, right? And that's what we're gonna do but our class is gonna be way simpler than the examples they have here. I've actually got this prepared already, so let me paste it in. There we go, there we go. Right, so we've got this, this abstract callback with the call method that takes test event, and we've got the callback mock, right, that inherits from this abstract class. And here we use the mock method macro, and that mock method macro takes 4 arguments. The first one is the type returned by the method that we're trying to mock. Then we have the name of that method. Then we have all the arguments that it takes, right, in the parentheses. And the last one is the override, right? That's just to indicate that we override it. Cool. So that's how you do it. However, for this code to work, we need another include. And that include is gmock, I think. It's, yeah, gmock again. I think this is it. Yeah. So that's what we need. Also, what is useful to write all of this, because we're gonna be using lots of functions from the testing namespace. So using namespace testing is gonna come useful. So I don't need to do testing prefix everywhere like I did. Like this is actually done. This is an example, a good example here. Like this is done here, right? This one is just a single call, but here we're gonna use it more with the mocks. But yeah, let me show you. Right, so we got EventDispatcher, 2 test events, and let's create our mock now. Okay, so callback mock and mock and mock. Right, so having this mock here, I can now pass everything here by reference. So it will have access to the outside, those 2 listeners. And what we could do is to call on the mock with the E, right? We can do it here and we can do it here. So that allowed us to create the 2 nice listeners that just call this mock, right? And because they call this mock, now I can write an assertion. I can write an assertion, which can be here, right? Outside of those listeners, right? You don't need to specify anything inside. Expect for the mock call, and you can still verify the types of the E passed here, its members, and so on. But yeah, let me show you how you do it. And you do it with the expect call. Again, for the expect call, you can find the documentation here. I'm pretty sure there should be somewhere expect call, not really here. That would be in the cookbook. So expect call, yeah, that's it. It is explained in here. The nice, the strict, and the nuggy, right? So in the cookbook, you can find the documentation for the expect call. There's probably more on their GitHub, but you will see this is pretty straightforward how you use it, because what you really are supposed to pass is the mock itself, and then the method, right? And then inside the method, here you can specify what you would like this method to be called with. Right, so that doing expect call, it's gonna expect that this mock call is gonna be called, and we really care what is it called with, right? What we could check, potentially we could check for the pointers if that E points to the same address as E1 points to. That would be possibly a verification. We could try, however, it might not be the same address because all of this void pointer logic that we have here. So you know what? I'm gonna test it myself, but I'm gonna test it myself with the pointed, checking if it points to the same E1, because it actually might not to. And instead of that, I'm just gonna test on the ID, right? I'm just gonna do it on the ID. So for that, you could do field test event. You need to tell what sort of field this is. So we're gonna do on ID, field ID. And then the second argument is EQ, that means equal expected, sorry, that's not expected even, that's E1 dot ID, right? So that's what I'm gonna do. So I'm gonna check if the given, to the mock call, the given event pointer field ID equals to E1, right? So that's the first call that we want to check. So yeah, that seems a little bit more complex, but really, let me show you another example. I'm not really gonna go with this one, but so imagine you just want to do a simple equality test, right? So you would like to make sure if the call has been called with, let's say, just a 1, right? As a number 1. So you do something like that. You use equal. You could use different ones. You have things like, I think this is at least, you see, less equal. There is lots of them. There is lots of them in the GTest, sorry, not GTest, in the GMock. Matchers, right? It is in matchers. So you could have a look at the code. Or even better, if you look here in the reference, you've got the list of all of these matches, right? The one I used is EQ, equal. So this is that one. An example I've just showed you, right? That was with EQ1. And the field one that I'm actually going to use is probably somewhere here, right? So that is member matches. Member matches, argument field, when argument is plain pointer, matches matcher M, where argument is an object of type class. So that's what we could do. And that's what I actually do, right? So this is one thing. This is just a single expectation on the call. We're gonna need 4 of them, and the first 2 are on E1, and the second 2 are on E2, aren't they? Right? So that's what we've got. Got 4 expectations for 4 calls. And let me run the code, let me run the tests now. You know what? Let me specify environment as native, because I don't really wanna run embedded tests. Okay, that failed for some reason. Let me check why. That did fail because I think there is something I forgot. Expected to be called once, called twice. Oversaturated and active. Oh, okay, I know why this is happening. Yeah, it didn't sum it up because this is not running sequence. That's one thing. This is one reason. Or, you know what we could do is to just specify the times we would like this to run. So we don't actually need 4 expectations. We just need 2 expectations. And let's test it like that. Oh yeah, you see? So yeah, that was the issue. Because if you want to run all of them like that, you need to put them in sequence. I'm gonna show you in a second, because we really want to check that with the sequence. But essentially, because they were equal, as you can see, right? These are 2 identical expectations. Instead of, you know, defining the same one twice, right? Duplicating yourself, you can just use times method to tell the Google test that you expect this to happen twice, right? You expect this to happen twice. Cool. Right, so that's one thing. I'm gonna try to break the test now on purpose. So to do that, let's go to EventDispatcher maybe. And so maybe let's go here and maybe let's add here true, or true, sorry. Oh, true. So all of the listeners now are gonna behave like once, right? So they're just gonna run once, and now we should get the tests failed. And that's the case, right? That is the case because I think this is not being run twice, and that is the reason, right? Expected to be called twice. Okay, so we have actual function, that's the 32. Expected to be called twice. That is on E2. That is on E2. And E1 seems to be okay. And this is the case, right? Because now it behaves, the on behaves like once. So it just runs all the listeners once. Let me just fix the code again to work again and run a native again. Right, now they okay. Okay, so yeah, that actually covers the test, this production code very well, I would say. However, I would also like to make sure that this is not that order. So it's not E2, right? That is called, all the listeners on E2 are called first, but E1. The E1 listeners, right? So, I mean, you know, listeners calling the mock call with E1, they should be called first, right? They should be notified first, right? Because that was the first event that we have dispatched. I don't want this to happen other way around. And I think if I just do something like that the other way around, this is not really gonna change anything in this test, right? This is all happening anyway. It's passed. The test passed. And if I somehow, let me think about it, if it's easy to do, change the behavior here to dispatch them in a different way. Or maybe that's too much work. Yeah, that's too much work in the code to deliberately fail this test. But yeah, to be honest, yeah, let's just then go with the easier approach. So let me introduce in sequence, which is again very useful with GoogleTest. So with that, we can make sure those calls are actually happening in sequence, right? So first we're gonna get this call, right? So 2 calls with the E1 and then 2 calls with E2, not the other way around. Let me try to run this. That should actually succeed. And that succeeded. And if I swap them, it is going to fail. You see? And that's what it says. They're not immediate prerequisites, not satisfied. Tried expectation first. Is an object given equal pointing to 2, 3, 4. Actual, which points to an object was given pointing to 1, 2, 3, right? So it's not correct. Expected to be called twice, right? So in sequence helps you to make sure the order of calls has been right. Cool. So yeah, now this works, right? So this is how you can simplify it, and that's how you test with the GoogleTest and GoogleMock. You know what? Before we finish, maybe let me add another test for the ones. Yeah, let's do ones now. That should be pretty straightforward. So we just do copy paste, and we check test listeners set with once method have been notified, maybe let's say when there was an event dispatched of the same type, maybe of the same type dispatched, right? Yeah. So test listeners set with once method have been notified only once when there was an event of the same dispatched, right? And here, what we're going to do is to keep two events, keep the dispatcher and the mock, but this time, we don't really need in sequence, but this time, we're just checking the first call. This is it, right? There should be just a single call. Even though we have, single call, there are two calls, right? Single expectation, two calls on E1 only, right? So we've got two listeners. They should be called one each, right? So just two calls in general, even though we actually dispatch two events, right? And this is because we use once. This is because we use once, and once is now the subject of the test with the dispatch, obviously. So now if I run it, that all works. I can even show you if I change that to on, the test should fail because we're gonna have more than expected number of expectations, right? So it is smart enough to tell if there was more calls than expected, which is pretty cool about the GoogleMock. There is nothing else you need to do except for this. Yeah, so this is a little of code that needs to be added. Nice. So yeah, so this is how you would do EventDispatcher. I think that covers pretty much everything on the EventDispatcher itself, right? I could do some extra experiments with checking whether, the test event here actually points to E1, but I'm not really sure if this is the case. And also, I could now write a test to any class here, right? And you know what? I actually did. So before we finish, let me show you quickly. I'm not gonna be writing it now. Just gonna show you how I did timer, because timer happened to be a slightly different case where we use some ESP8266 native code. And that native code is the millis, right? So what I had to do, I previously had a now method here that just returned the millis. And now this is a std function that you can set by passing the millis function to the constructor. Essentially, you just need to pass a function that returns unsigned long, and that should be the number of milliseconds. If the environment is Arduino, that constant is gonna be present, and because of that, you can have the ESP8266 specific code, right? So this is ESP8266. That's not gonna run on native, and on native, you are supposed to pass. There is no default value for that argument. You are supposed to pass this function because this is the only native ESP8266 native piece, right, that we've got here. And by separating it, I can test timer natively. But the way to test it happened to be a little bit tricky. And that was because if you look at that, so for millis is easy, right? I just use chrono system clock. So that's works very similar way that millis work on ESP8266 when the clock is synchronized, right? Because if it's not, it just starts from 0. We still got timeout callback. I just called it timeout callback instead of callback, but it's still just, callback with the call method. And that's the mocked, right? That's mocked method. And here I've got two tests. So the first test tests set timeout. So tests if the set timeout calls given callback after given amount of time, right? So because this is a bit tricky, right? We don't really have a loop function on the native environment, but we still have while that we could run with the timer tick. And that's what this is what I've done, right? So I set up an expected time for the future, right? So the actual time plus 500 milliseconds. And I expect there is a call on mock, right? That is between expected time minus error margin and expected time plus error margin. I don't know, there was a very small error margin for milliseconds on the native environment for some reason. So I had to add this 3 milliseconds, right? So this is just between. All of means whatever you pass in here, right, needs to comply with all of these matches, right? So we have greater equal expected time minus error margin, and this is like and, right? So all of it is like this matcher and this matcher, less equal expected time plus error margin. And that needs to run just a single time, right? And that's what I do on the set timeout. I just run this mock call with the millis, with the actual millis. So we can check the actual time at this moment when the callback is called. And because of that, this assertion can happen. So we can make sure that was really the time to call this callback, okay? And that's basically called with the interval. And then we use the timer tick that runs on the loop until the expected time plus error margin is not actually now, right? So this is gonna run as long as the actual time is less than the time that we set as the expected time, right? Because if by that time, right, by the time this while finishes, we don't register any calls of the mock call, that means the test has failed, right? So that's how this works. And this one is on set interval, very similar way, but because it's interval, we expect to get more calls. We expect them to get them in sequence on these particular times, right? So that is interval times 1, interval times 2, interval times 3, right? So this is after 100 milliseconds, 200 milliseconds, 300 milliseconds. And this one now runs until this whole interval, like, you know, all of these 3 calls that we expect happen, right? Essentially, there's going to be more calls, but we don't care that much because we just want to make sure this is like continuous case, right? This is called continuously on the set interval right here. Okay, yeah, so this is how you write these tests, and I'm gonna write more. Let me please know in the comments if you would like to get more videos like that, where you know, I step by step write some code and explain what I do. And also let me know if my explanations that I gave today are also clear enough, right? Because if there is something that is not clear enough, I will try to do, actually I will do a video that clarifies whatever is not clear yet. Yeah, so that actually concludes today's video. And now let me tell you what we're gonna be doing tomorrow, because tomorrow, another coding session, a bit advanced. So I'm gonna tell you now, this is gonna be a bit advanced video, because what I would like to do is to build my own futures, aka promises here. So I can run Wi-Fi manager or a single host HTTPS client in a non-blocking way, but returning the future object instead of taking the callback, right? So with that, we can chain those, right? So we could do something like connect to Wi-Fi and then send the request and then do something else, right? So we could chain them in a nice way, and this all will happen in a non-blocking way on the loop function. But yeah, that's gonna be tomorrow. And this is it for today. Thanks for watching. If you would like to stay up to date with my channel, don't forget to subscribe. Cheers!